All right, today we're going to talk about rate of change. So what is a rate anyway? So rate is when you're comparing two quantities with different units. So in this example, we're comparing values of x and y. So how do we find rate? Well, in Algebra 1, you learned to find slope, rise over run, right? So my rise is the y values on the thing changing that's going up and down, and the run is the x values, the thing moving left to right. Okay, so you've probably seen this formula for finding slope. So this is the change of y over change of x. Okay, so now, so if we've got, sometimes it's not always, we're not always using x and y. Sometimes here we have like changing distance versus changing time. So here we would have the difference of the y values in the numerator and the difference of the x values in the numerator. And if we were using these units, the units would be kilometers per hour. Okay, so when you're doing change of a rate change, kilometers per hour, you might have heard that that's in physics that's called velocity. Okay, we're talking about how fast are we going per hour. Okay, that's an example that we'll be using in the next few weeks. Okay, so when you're calculating the rate or the slope of a straight line, you're going to get a constant value. So in this example here, I've got these values 1, 2, 3, 4, 5, 6, and these values 1, 2, 3, 4, 5, 6. I pick some points. Here I've got a point 2, 1. Here I've got a point 4, 2. So the change slope is rise over run, correct? So the rise, it goes from 2 and 1, so 2 minus 1 is going to give me 1, and the run is in the x direction, we're going 4 minus 2, which is going to give me 1. And you could tell that it's got a slope of 1/2, right? So don't forget the units, liters per minute. Okay, so this is some of the examples we're going to be doing. Okay, so now what if the rate changes? So here we've got a graph that's not a straight line, it's a curve. So depending on where you are at, the slope changes. So the rate will be different depending on what part of the graph we're using. Okay. So to find the rate at a point, we must pick 2 points really close to each other. Okay. And then eventually I'm going to show you how to do it if it's at a particular point. Okay. So, and one last part before we go further. So there's 3 words we're going to talk about that you need in your notes. Tangent is when you've got a point that touches a curve at one spot. Chord is a line that touches a curve at 2 spots. So in this example here, the chord touches right here and right there. And then a secant line is a line that cuts a curve in 2 spots. So this is a line because it goes forever and ever each direction. A chord is a segment, so it starts and ends right there. And that is your notes for 12A Part 1.